All right, need a little help now. Okay, need a little help. Ready to go? Because this is really about it here. Because we move on to something brand new. We are going to hit this up again tomorrow and Thursday though. Okay, 250 degrees into radians. Hopefully by now we know where to go on the formula sheet, what to multiply by, how I want the answer left, not as a sloppy decimal. All right, as something nice and clean with pi in your answer. So I take my 250, and according to my formula sheet, here we go, 5. What do you want to multiply by? Let's go the original numbers. The original numbers. Pi over 180. I do not want you to multiply all this in your calculator because that will give you your sloppy decimal. Instead, I want you to keep pi in your answer and just do 250 divided by 180 and give me that as back as a fraction. And as a fraction, that should have been 5 again. Hi, Mary. 25 over 18. Yep, just the zeros canceled out there. There you go, 25 pi over 18. All good. Okay. Draw an angle of negative 2 pi over 3 radians on my graph here. So probably I'm assuming most of you converted it first, right? Okay, what is negative 2 pi over 3 in degrees? 18. Good talk. That was fun. 8. Thank you, man. Negative 120. And I can't wait till the next couple days when I get to show you guys that you can just look at negative 2 pi over 3 and find out that it's negative 120 without doing anything on your formula sheet. You'll just know, oh, that's 60 times negative 2, negative 120. It'll be fun. It will be, Ashley. Got it? Negative 120. What quadrant am I in? Oh, 5. Oh, on fire, Mary. Let's go. Quadrant 3, because I go 3? Yeah, it is 3. Never mind. Negative 90, negative 180, negative 270. Got it. So my initial side, always on the x-axis. Not off the hook yet. Closer to 180 or 90. Nice job. And I still need what here? Because there's 2 different ways this angle could be formed. Jenna? Yep. Any issues yet?
I have a question. So on mine, I labeled like these positive. Is that wrong?
I'm not looking at that, Art. Here's what I need to see. It's in the 3rd quadrant, closer to 90, closer to this one here, and the rotation arrow is going in the correct direction. I don't care what else is on there. Okay, I'm not looking for that. Hi, Ashley.
So, the arrow rotation.
Yep.
Which, like, is it that way if it's negative and that way it's positive?
Counterclockwise, going this way if it's positive. Clockwise if it's going negative. Yep, think of a clock. Which way does the second hand move? It's fine. You're not the only one because you guys live on your phones and you're digital. So, an old school clock kind of. All good? Okay. Anybody else before I move on? Okay, what's the reference angle for this angle? Reference angle. Again, the first part is knowing where it is on your diagram. How's the reference angle formed? Terminal side and x-axis. So it forms what type of angle? Acute. So it's got to go, I'm looking for this angle right there. Okay, always positive. I don't care if I started out with a negative degree measure, it's always positive. So first, in degrees, what is this angle here? In degrees, what's that angle right there? Oh, 14. 60 degrees, good. Anybody need to go over how she got 60 degrees? Okay, but it did say in radians. So do you have the radians version, Ashley? Pi over 3. That's one you guys are going to know pretty quick by the week's end, that pi over 3 and 60. Questions? Okay, final one. In radians, find a positive angle that's coterminal with negative 120. So negative 120. How'd you find a positive angle? What did you do with it? 17.
We don't have some.
You're just,
I love that.
but yeah, you do. Good. I'm glad. Five.
I forget the question now.
Negative 120. Find an angle that's coterminal with it. Oh, what do I have to do to negative 120 first? Even before I do that, I should probably... Well, what did you do, Mary? I'll go with what you did. What do you mean? I have negative 120, right? An angle that's coterminal, so shares the same terminal side. You go, we should add or subtract what to it? So I add 360 to it, and I get 240, but what did the problem say? In radians, so you multiply this by pi over 180, reduce, and that turned into what? Pi over 4 pi over 3. Good. All right. Questions, or anybody want to share differently how they did it? Okay, we should be pretty comfortable now, right? We spent 3 days on this, including a group assignment, because I'm going on to something totally different now. All good? Nick, how do you feel back there? Great. All right, let's roll, guys. Here we go. This is a short notes today. Page 9. We are still working with radians. I'm going to introduce a new formula to do some of these word problems now. All right, but before that, we got to review some geometry terms from 10th grade. Here's my example. If the radius is 4, we all remember where the radius was? Radius from the center to a point. So if my radius is 4, and the intercepted arc, so the arc length is 8 units, right? So if you just have anywhere on your circle here, 8 units, draw in for me another radius. Okay, draw in another radius for me. So again, radius is 4, arc length is a length of 8. I want to know how many radians. Everyone see the angle that's formed? Everyone see the angle that's formed? How many radians are in that angle that I form? Okay? And I'm going to show you guys a formula today. All right, a formula. It is the following. It is a very, very short formula. Unfortunately, bad news. Anybody know my bad news? It's not on the formula sheet. Okay, not on the formula sheet. Okay, it is the following. Theta, our Greek symbol theta, equals S over R. I don't know, maybe you guys did this in geometry a couple years ago. I don't know if they did it back. I have no idea what you're talking about. Sure. No, it's not. It's not. Sine, cosine, tangent. No. It's coming up. It's coming back up this unit, trust me. Yep. Yep. Pocahontas' brother. Sokotoa. Did you ever know that? That's where that came from. Pocahontas' brother. You never knew that watching the movie? They don't bring that up in the movie. Sokotoa.
I thought you like hung out with a raccoon. Wait, what was the dude's name?
I'm not moving on. I should have never brought it up. Never brought it up. I should have never brought it up. All right. You have 3 parts to this formula. 3 parts. Ready? Theta. That is the angle in radians. All right. That is the angle measure in radians, not degrees, in radians. And then there is S. S stands for the arc length. And then finally, there's an R value. Guess what the R stands for? Radius length. All right. This is any problem we're going to do here involving the circle, the arc length, and the radius. So let's go back to our example that we had right off the bat. What am I asking you to find in this problem? The first example here. What am I asking you to find? The angle measure. The angle measure. So out of these three, what am I asking you to find? The angle measure. So which one represents the angle measure here? Theta. Theta. So we're going to say theta equals, what's S represent? Arc length, which we were given was what? 8 over R, which is the radius length, which I gave you as 4. Okay? I'm not doing a tough one here. 8 divided by 4? 2. So there are 2 radians in that angle. Okay? 2 radians in that angle. When the arc length is 4 and the arc is 8 and the radius is 4. Forms an angle of 2 radians. Do I need you to convert it? Nope. Nope, 2 radians. Questions? Let's go. One doesn't make you great. Now we can start flying a little bit. A circle has a radius of 1.7. Find the arc length. Oh, now we're solving for a different letter. Find the arc length whose central angle is 2 radians. All right, so I see, here you go. Hey, this signifies it. I got arc length. I got radius. I have to be using theta equals S over R. All right, ready to get called on here. What's my theta value now? What is my theta value? The angle measure. Here you go. 5. Look at, this is unbelievable, Mary. What is the angle measure in this problem? 2 radians. So I'm just going to put 2 equals. Good job. And what does the 1.7 inches represent? And where should I put it in the formula? 12? What's the 1.7 represent? So where's it going to go in for, Nick? R. Darn right. 1.7. What's it asking me to solve for? Find the length of the arc. So I'm solving for S. How comfortable are we solving this? You guys can cross multiply. You can multiply both sides by 1.7. It's your call. But at the end of the day, what is the arc length? 19. 3.4. Yep. How's that look? All right. Ashley?
Do we have to write
Units?
Yeah.
There's other things I got to worry about. All right. I'm not going to get that. And on the regions, they don't care either. So, all right. There's other things I'm going to make sure you pay attention to detail too. And that's not one of them. Okay. Everyone working out all right here? Okay. Let's get it going now. Yeah. Yep. Minute hand on a clock. Ready? Everyone know what a minute hand is? It's a shorter one or a longer one?
Well, come on.
Settle down. I corrected myself. Longer one.
But there's 2. Isn't it the red one? It's not the red one though. I know.
I think the red one's broken.
The red one's the red one's not working.
Okay, it hasn't been working all year.
It's the one that's by the 5. Maybe we can knock
Thank you for the update.
Sometimes it
Thanks.
doesn't work.
Okay.
It's not working right now. No.
It hasn't been working all year.
Yeah, I know.
The clock works, it's just not the second hand.
I don't know because I like
It doesn't bother me.
You got your
I know what time it is.
Oh,
I know what time it is.
We're like Mets.
Never compare yourself to me, Art. Okay. All right, here we go. All right, right off the bat, determine the number of radians. So what am I going to solve for right now? Determine the number of radians. Determine the number of radians. Not the radius length. Determine the number of radians. So the angle measure, what's going to be solved for here? Theta, all right? But now I don't come out and say, here's the radius, here's the arc length. I put it in terms of a clock, and you have to help me find out what's S and what's R now. The minute hand of a clock passes through if it has a length of 5 inches. So the minute hand has a length of 5 inches. What's the minute hand acting as? The radius, perfect. So I have equals, theta equals something over 5, and its tip travels a total distance of 13 inches. So does everyone see how that's the arc length? Yes? No? Here. All right, the minute hand going around right here, and see how that's the edge of the circle. We good? Yep, hands-on demonstration. Darn right.
It's like, it's. Oh, Ashley. Yeah, no? Okay.
13 over 5, 2.6 radians, right? Okay. Yep.
Can we play the game you play in your other classes where you go kids
I don't know what you're talking about. No idea what you're talking about.
I was there.
You're spreading rumors. Okay, sorry. You're spreading rumors. Fake news, yep. Yep. All right, next one. Well, there's our pendulum again. Swings through an angle of 0.55 radians. What's the distance the tip travels if it has a length of 8 feet? All right, can you now, on your own, figure out what's theta, S, and R here? What am I solving for, and what are the other two values I need to plug in? 17. Don't have one, guy. I was on that one, Marissa. Get out of here. 10. How do we not?
What? 10? That's me.
Okay, all right, ready? What's theta?
0.55.
Here we go. 0.55 is equal to, how about S, Art? Just S, because I'm looking for what distance does it travel, and what's the 8 represent?
That's your R.
That's my R value, yep. Are we comfortable solving something like this? Grace, are you comfortable solving something like this? Great. And what do we end up with? 9, what do we have? Hey, that's been pretty easy so far, right? Right? Until we get to number 4. Oh, what's the big deal, right? It's just another pendulum. It's swinging an angle of 30 degrees. The tip travels along a length of 4 pi. Find the length of the pendulum in inches. All right, no big deal. What's my theta here? I don't have an angle measure?
No, you have to like.
Swings through an angle of 30 degrees, but you're not plugging 30 in there. You are not plugging 30. Go back to when I originally showed you this formula. What's theta? The angle in. You cannot use degrees in this formula. No go. But what do you have the ability to do over the last 3 days? Convert it to radians. So that's what you need to do first here, is take your 30 degrees off to the side and convert it to radians before you plug it in for theta. How are you going to convert it? Multiply by number 16.
Oh, that's me. Pi over 180.
Yep. Leave the pi in your answer. Reduce 30 over 180. What do you got for me?
1 pi over 6.
So in place of theta will be pi over 6. Everyone all right there? It has to be in radians before you use this formula. Got me there, Maddie? Great. And now what's this 4 pi inches? That should be the length it travels, which is 4 pi. And we're solving for the length of the pendulum, which will be S, or R, excuse me. Got it. Good, cross multiply. So you'll get what? Pi times R equals, what's 6 times 4 pi? I'll just leave it 24 pi. Everyone all right where I'm getting these from?
Yeah.
And then what am I going to have to do on both sides? Divide by pi. If you want to do it in your calculator, you don't have to, but $14 when you're ready. What's my radius length?
Radius length is
24. Yep, go ahead, Jenna.
This is really stupid.
Nope, go.
Can't the pies cancel out?
Where? Not here, not here. Well, if you divide both sides by pi, yes. That's where the 24 comes from.
Oh.
Yeah.
Thank you.
Yep. Not over here, though. But you can, once you divide by pi, yes. All right? Everyone all good? Okay, one more, and then you can get to the assignment. Okay, the steering wheel on a monster truck. Here we go. Yep, get her done. Here we go. Anybody ever been? Anybody? Monster trucks? I don't know. I've never been myself. You have, Michelle? You got to put the too loud, or you got to put the, because that's what you were fine. Might be the little kids, because it seems like every time I see a picture of a monster truck rally, they got all the little kids have the earphones. Never. Class trip, yeah, maybe, yep. Class trip, yep. Anybody else been? Anybody? Okay.
I'd like to go.
All right, hey. Aren't they at the Times Union Center every once in a while?
I'll bring my mom.
Yeah. I was thinking the right guy.
All right, so here we go. It's got a radius of 11 inches. How far does a point on the steering wheel travel if the wheel makes 4/5 of a rotation? Oh boy. All right, so let's see. Is there anything we can definitely be confident in to plug in for SR or theta right now? How about that 11 inches? In for R value, yep. What am I solving? What am I asking you for? How far does the point on the steering wheel travel? That's my S. Watch, right? Here's your steering wheel, right? How far does it travel? There's your steering wheel. How far does it travel when I turn this thing 4/5 of a rotation? So does everyone see I'm solving for S? How far I'm going to turn it, the travel, right? All right, now we got to talk. How the heck do I find theta then? 4/5 of a rotation. Rotation, go all the way around. How many degrees am I going, Alex? Oh, go ahead, or say what you were about. Okay, so all the way around, everyone agrees I'm going 360, right? All right, so I take 360, and I want to find what is 4/5 of 360. Yes, is that what you're going to say, Ben?
Yeah.
Great job. That'll tell me how many degrees I'm rotating. So if I'm at 360, you go 4/5 of that. How many degrees did I rotate? 288. Hold on, though. Have we learned anything here? I don't plug that 288 in for theta. Why not? It's in degrees. I only plug what into the formula? Radians. Time to convert. 288. What are you going to multiply it by to convert it? Oh, let's hear from 19. Pi over 180. Yep. Reduce, reduce, reduce. Keep pi in your answer. I got to figure out what that does. Like, I trust you. 8 pi over 5. And it does say round to the nearest tenth. Where are you going to solve from here? How are you going to, yep, solve for s. How? How are we solving this here for s? Multiply both sides by 11. You could cross multiply if you wanted to and say 5s equals 8 pi times 11. It's up to you, but go ahead and round to the nearest tenth for me.
You don't have a 17.
Can't even get it out. 15. Do we have a 15?
Don't know where 15 went.
Oh, that's right. To be nurse. 3.
Oh, that was
55.3. Nice job, Ben. Okay. There's only 7 questions tonight. 7. All right. Try to find 10 minutes tonight to get those 7 done, because it seems pretty easy when we're doing it in class, but then you get in front of you on a test and you forget how to use it. Okay, even though it's a simple formula. Brett, I don't know what we're talking
Why
about.
does it say Kevin's out?
And that's what they do.